Assalamualaikum and hi, my name is Naresh Mustafa and I'm going to start presentations with the DFD cycle. So, the production cycle begins when the sales department send customer order information into process 1.0, which is called Prepare Master Production File. At the same time, the inventory file also sends inventory levels into process 1.0. Using both of these inputs, process 1.0 prepares a production plan and stores the data into the master production file. The master production file then sends back master production file information into process 1.0 as a reference. Once the production plan is ready, it flows from process 1.0 down into process 2.0, which is called prepare bills of materials. Process 2.0 then breaks the production plan down into a detailed list of every raw material needed, which is known as the bills of material, and save a copy into the bills of material file. The raw material needs are then passed from process 2.0 forward into process 3.0 to continue the cycle.
Next, I will present about the process 3.0, which is prepare material requisition form. This process received the raw material needs from the earlier process 2.0, which is prepare bills of material, which had already calculated the raw materials required based on the bills of material stored in the bills of material file. Once process 3.0 receives this input, it generates the material requisition form, and this form is distributed into two external entities. First, it is sent to the purchasing department so that they are aware of what materials are required and can arrange procurement if there is a shortage. Second, the same material requisition form is sent to the storeroom department, instructing them to release the materials that are already available in stock. At the same time, process 3.0 also records these transactions into the material requisition file, which acts as a data store to keep a history of all requisitions made, useful for tracking and audit purpose. So, once the storeroom department processes the requisition, the actual material is released and flows into process 4.0, process of production. This is where the physical production activity takes place, using the materials released from the storeroom. However, what's important to highlight here is the feedback loop. During production, if there is a discrepancy between the materials planned and the materials actually used, process 4.0 generates an additional material report. This report flows all the way back to the bills of material file. This creates a feedback mechanism within the system, allowing the standard bill of materials to be reviewed or updated if actual usage consistently differs from what was originally planned. This reflects good internal controls because it means the system doesn't just plan and execute blindly. It also monitors and corrects based on the real production data.
Now, I will take my turn to continue from the process 4 to the warehouse. After the manufacturing is complete in the process 4, the employee's information flow from the process 4 down into the process 5, which is called prepare job time ticket. Process 5 uses that information to prepare a job time ticket, which record which employee worked, on which job and for how long. The job time ticket is then sent from the process 5 to the accounting department for labor cost calculation and payroll processing. After that, the flow continues from the process 5 down into the process 6, which is called store finished good. Process 6 then formally transferred the complete product as a finished good to the warehouse, which marked the end of the entire production cycle, and the product are now ready to be delivered to the customer. The first activity in the production cycle is a product design. The objective is to develop a product that meets the customer requirement in terms of the quality, durability, and the functionality while minimize the production costs. For the prime can industry, this activity focuses on the specialization, manufacturing aluminium beverages can for the food and beverage industry. A critical output in this stage is the bill of material, which lists the part number, description, and quantity of every component to use in the finished product. At the prime can, this document is essential to identify the specific raw material required to reach their production target.
Next, I will explain about the planning and scheduling. Planning and scheduling is the process of planning what product needs to be produced, how many units should be produced, and when they should be produced. The main objective is to ensure the company can meet customer demand while avoiding too much inventory, which can increase storage costs. There are two methods of production planning. First, MRP2, where production is based on demand forecast. This means the company estimates future demand and produce accordingly. Second, lean manufacturing, also called pull manufacturing, where production only starts when there is actual customer demand, helping to reduce unnecessary inventory. The result of this process is the Master Production Schedule, which is MPS. The MPS shows the quantity of each product that needs to be produced based on the customer order, sales forecast, and finished good inventory levels. In Prime Can Industries Sendirian Berhad, the supervisor review customer order received from the sales department and check the current inventory levels. Based on this information, the supervisor prepare and record the master production schedule to guide the production process.
Now, I will present about the third activity in the production cycle, which is production operations. So, the main objective here is companies want to manufacture products efficiently following the production orders and schedules that were already prepared in the earlier planning stage. But it's important to note that how this objective is accomplished varies greatly across the companies. There is no one-size-fits-for-all approach. It really depends on two things, which is the type of product being manufactured and the degree of automation the company uses in its production process. Next, so how does this actually happen in practice? Workers carry out the production activities by referring back to the production orders and materials requisitions that were prepared in the previous stage. So there is a clear paper trail connecting planning to execution. To support this manufacturing process, most companies today rely on computer integrated manufacturing, or we call CIM. CIM involves using technology like robots and computer controlled machines directly on the factory floor to carry out production tasks with a greater speed and precision. On top of that, companies are increasingly using equipment sensors connected through the Industrial Internet of Things, IIoT. So these sensors allows the company to continuously monitor the condition of its machines and perform maintenance before a breakdown actually happens. This is what we call predictive maintenance, and it's a huge shift from the traditional reactive approach because it prevents unexpected disruptions to productions. And here is the biggest strategic impact. Because of CIM, companies are no longer limited to mass producing large quantities of the same product. They can now produce goods according to a specific customer needs. So this is essentially mass customization, but this flexibility comes at a cost. It requires the company to constantly update its inventory systems and production workflows so that they can handle these changes quickly and flexibly. Next, let's apply it to our case company. Firstly, workers collect the required raw materials, for example aluminium, from the storeroom based on the materials requisitions that were issued. They then proceed to manufacture the beverage cans. Once production is complete, the finished cans are packed, labeled, and transferred to the warehouse for storage and delivery. This shows the full cycle from requisitions to manufacturing to finished goods being ready for distribution.
So now we move on to the last and final basic activity in the production cycle, which is cost accounting. So the main objective of cost accounting is to track and record all manufacturing costs accurately. This includes assigning costs such as direct materials, direct labor, and manufacturing overhead to the units produced. It also supports accurate financial reporting and inventory valuations, and most importantly, it aids management in making informed decisions such as pricing strategies, budgeting, and identifying the root causes of rising production costs at Prime Can Industries. So, how exactly is cost accounting applied at Prime Can Industries? First, in terms of pricing, cost data is used to set selling price based on the total production cost, ensuring the company remains profitable. For budgeting, management use historical cost data to plan and forecast future costs more accurately. Cost accounting also plays a key role in cost control. By identifying and investigating any rising production costs, management can take corrective action early. It helps with inventory valuation by determining the value of both finished goods and work-in-progress items. And finally, for financial reporting, all cost data is transferred accurately to the general ledger, ensuring reliable and complete financial statements.
The first one, we're focusing on the turf of inventory. The current trade at the Prime Can is when the workers request an additional material verbally, but without the formal documentation. This creates the high risk because the company cannot track the inventory movement. It is impossible to verify whether the material is really used for the production or misappropriated. This lack of control slightly contributes to the company rising production cost. To mitigate this, we propose two controls, and the first one is material requisition must be mandatory for all released and authorized by the supervisor. This ensures that only necessary material are issued, avoiding the over-purchase of unnecessary items. Second, we must implement a dual signature procedure. Both the inventory clerk and the production employee should sign the requisition to acknowledge the official release of goods to production. This step establishes a clear accountability and protects the company asset. Next, the second major trade at the Prime can occur when the workers collect the material from the storeroom without oversight. The risk is that inventory might be stolen or misused without being realized. Directly, it will contribute to the company rising production costs. So, to mitigate this, we propose 3 controls. The first one is to restrict the physical access using access card or CCTV to monitor the storeroom. Second, establish a segregation of duties so those who handling the physical inventory do not manage the inventory record. Finally, an independent person must periodically count inventory on hand. These counts are necessary to detect any discrepancies between the physical stock and the amount recorded in the inventory file. The step will provide the oversight needed to protect PrimeCan asset and improve production efficiency.
As for my part, I will explain about the theft of fixed asset. First theft is incomplete fixed asset record. PrimeCan does not maintain a complete and updated record of its fixed asset. As a result, if an asset is missing or stolen, management may not be able to detect the loss or identify who is responsible for the asset. Therefore, the company should maintain a complete asset register and assign responsibility for each asset. Next, no access restriction to machinery storage. The machinery storage area does not have proper physical access control, allowing unauthorized individuals to enter easily. This increases the risk of theft or misuse of machinery and may cause production delays if equipment becomes unavailable. To mitigate this risk, only authorized personnel should be allowed to access the storage area, supported by security measures such as lock, access card, or CCTV. Lastly, no formal approval for asset disposal. There is no formal approval process for disposing of old or damaged machinery. Employees may remove or sell asset without management's knowledge, resulting in financial losses and inaccurate asset record. Therefore, all disposal should require management approval and proper documentation before any asset is removed from the factory.
So, let's move on into suboptimal investment in fixed asset. So, the first threat is overinvestment. This happens when a company purchases machinery that exceeds its actual production needs. So the possible risk here is that this unnecessary capital expenditure increases operating costs and ultimately reduce profitability. The second threat is the opposite problem, which is underinvestment, which is continuing to use outdated or insufficient equipment. This creates a different kind of risk, which is production delays and rising costs, because the equipment simply can't keep up with customer demand. So you can see these two threats sit on opposite ends of the same spectrum, too much investment or too little, and both will hurt the company financially. So, to control the overinvestment risk, the procedure requires that any large capital expenditure be formally recommended by a supervisor and approved by a senior executive or capital investment committee before any purchase is made. This creates a layer of accountability and review before money is spent. For the underinvestment side, the procedure is prepared to form a request for proposal or RFP and send it to multiple suppliers before purchasing equipment. This ensures the company is comparing options and selecting the most suitable and cost-effective solution rather than settling for whatever is convenient. Next, the third threat is a lack of accountability over fixed asset spending at the department level. When no one is directly responsible for tracking how much a department spends on asset, the possible risk is that managers may make uncontrolled or unjustified investment decisions, especially spending without proper justifications. So the control procedure for this is to hold managers accountable for the return on fixed asset within their own department. By tying asset spending to measurable performance outcome, this encourages managers to make careful, well-justified spending decisions rather than treating capital expenditure lightly.
So now, let's look at the threats and disruptions that could affect the overall production cycle at PrimeCan Industries, along with the possible risks and control procedures to address them. The first threat is that additional material required are sometimes requested verbally without formal documentations. This is a problem because production may stop due to a material shortage, as there is no proper record to track material usage. To control this, PrimeCan should require a supervisor-approved requisition form before any materials are issued. The second threat involves employees manually recording their working hours for payroll processing. This creates a possible risk of payroll errors, disputes, and inaccurate reporting. To address this, PrimeCan should implement a biometric attendance system to improve timekeeping accuracy and verify time records before they are sent for payroll processing. These control procedures are essential to ensure the cost accounting remains accurate, reliable, and free from errors or manipulations. In summary, by identifying these threats and implementing the right control procedures, PrimeCan Industries can safeguard its production cycles, minimize disruptions, and maintain the integrity of its operations. Thank you.